Hello there, everybody. Here comes your warm-up. There it is. There it is. Make a coordinate plane go in 7 each direction. Graph the lines from the following tables and write their equations for those lines in slope-intercept form. You're going to want to pause the video, work on that, and then come on back because we are just about ready to go. All right. There we go. I'm going to zoom that out just a little bit. Okay. Make that go 7 each direction. One, two, three, four, five, six, 7. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, can I get you guys back up here in 5, 4, 3, 2, 1. So if you look at this one, it's negative 2, comma 1, negative 1, comma 3, 0, comma 5, and 1, comma 7. So if we connect those with a line like this, I need to know what the slope and the y-intercept are so that I can find the equation in slope-intercept form. Let's see here. Carol, what is the y-intercept of that line? Oh, the first one. Yeah. It's 5, right. It's 0, comma 5. So, and what is the slope? What's the change in y over change in x fraction? 2, very good. So what would the equation be? Awesome. How many of us got y equals 5 plus 2x or y equals 2x plus 5 for that? Perfect. Even though 2 over 1 is mathematically correct, it wouldn't be reduced, so we want to make sure we're doing that, just like Carol did. Here's another thing. Notice, guys, when I asked Carol for the slope, she said it was 2x. Be a little careful there. X tells us what the slope is, but x actually isn't part of the slope. So we would just say that the slope is 2. Does that make sense, Carol? Great. Excellent. Ooh. Who could that? Oh, sorry. Perfect. Thank you, sir. All right, let's see here. How about numero dos? Let's see here. We'll get that one in green. And then, let's see here. We're going to go negative 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Negative 4, comma 1. There we go. And then negative 2, comma negative 2. And 0, comma negative 5. 1, 2, 3, 4, 5. Perfect, thank you. Let's see here. Yeah, he'll be there in a minute. Okay. Avi, what is the y-intercept of that line that I've got here in green? Voice is off, guys. Go ahead, Avi. 5, okay, and negative 5. And what's the slope? Beautiful. And what would that make your equation? 3 over 2. And then don't forget, what do we need there at the end? X. Very good. Awesome. Whew. How many of us got y equals negative 5 minus 3 halves x, or y equals negative 3 halves x minus 5? Perfect. That's exactly right, guys. That's all there is to it. So you just need to find the slope and the y-intercept, and it helps you build that equation, okay? Go ahead. That's just fine, Holland. All right, guys. It is the 71st day of school. Since 71 and 17 are prime, both are emerps. Yes, that is a prime number who, if you reverse their digits, is also a prime number.
Oh, it's prime backwards.
Yep, exactly. Yes, exactly. Happy Giving Tuesday. Yay! Right, that's all part of the that super shopping week, right? So there's Thanksgiving, and then there's Black Friday, where you're supposed to go to stores. Cyber Monday. Did they skip Saturday and Sunday?
No, Saturday's small business.
Small Business Saturday. You're right.
And
It's Sunday.
Sunday is everybody's at church.
Maybe that's last Sunday, and then Monday is Cyber Monday, and then Tuesday's Giving Tuesday, where you give to like charities. Like maybe what you can do is like you can find a charity that somebody you know really likes, and you give a bunch of money to them, and then that's their gift. It's like I made this donation in your name. All right, let's see here. What do we got? Let's see here, Addie. What is our first essential question here? That's really is what it is. Yep. What can three cars, two apes, yeah, teach me about systems of equations. What can three cars, two apes, and a carrot teach me about systems of equations?
Ooh, I love
It happened in December. On December 20th, 1860, South Carolina was the first state to secede from the Union, kicking off this all American war. That was indeed the Civil War. Yes, the Civil War is the correct answer. And then Disney princesses, Ariel is what we're looking for. The Little Mermaid is indeed the name of the movie, but I'm looking for the name of the princess. So Ariel is correct. Look, it was the best Sebastian I could pull off under short notice. Okay, so here we go.
He's beautiful. I love him.
Got a pencil?
Absolutely.
Today, the topic is systems stories. And we're going to start by making a coordinate plane here. Guys, if you look over here by my catch-up basket, there are full sheets of graph paper. If you have one of our math notebooks or you've got a full sheet of graph paper, you do not need to grab one of those. But if you do not have a full sheet of graph paper, then you should go over there and grab one. Maybe send one person at your table to grab one for each of the people. Grab some of that graph paper for me, and we're going to make a pretty sizable coordinate plane here. Okay. 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 We're going to make a coordinate plane in quadrant one. We're going to make a coordinate plane in quadrant one like this. And it needs to go up 20 on the y-axis and right 12 on the x-axis. Now, you can count by 5s up to 20. You can count by 2s up to 12. You can do whatever you want to get to those numbers. If you can go higher, that's great. But you must make it up 20 and right 12. I recommend on your paper, guys, using every box as a single. So it should be 20 boxes high and 12 boxes long. I'm going to be doing something a little bit different on mine because otherwise it's really hard to see. So on mine, I'm going to count by 2s up to 20 or 12, excuse me, on my x-axis. But every 2 boxes is going to count as 1 because otherwise you guys won't be able to see. But I recommend you just count every single box as 1. Put the little midlands in. Okay. You can, but I think that you should, if you get a full sheet of graph paper, you should be able to make it happen, okay? I do not recommend doing that on this particular unit. 20 up on the y-axis, 12 right on the x-axis. See, I can make it to 25, and that's okay. But it only has to make it up to 20. Nope, nope, just quadrant 1. Just quadrant 1. Quadrant 1's all that's necessary. Behold the inner workings of uh, Mr. Petersen's computer files. Awesome. Okay, while you guys are finishing that up, I'll get us started here. A tale of 3 cars, 2 apes, and 1 carrot.
Yes.
Okay, here we go. 3 cars. Guys, I'm going to show you a couple of vehicles, or a few vehicles, and I want to see if you can correctly identify them as they pop up. Are you guys ready? So see if you can get the make and model. Okay, let's find out. I heard a lot of makes, but I didn't hear a lot of models. That's a. Does anyone know that? Here, let's try it again. So it's not just a Chevy, it's a Chevy something. It's not just a Subaru, it's a Subaru something. It's not just a Hyundai, it's a Hyundai something. Let's see what we got. That one gets it. That one gets him every time. That used to be a very popular car, but it doesn't seem very many people drive them anymore. Anyway, members of Mr. Peterson's family are deeply in love with their cars and very defensive about them. Each has a different fuel tank capacity and gas mileage. To make things easier, we're going to talk about gas mileage as gas used every hour while driving 60 miles per hour. And I actually looked up these numbers, and they're approximately right. I had to play with it a little bit to make these numbers a little bit friendly. But it is about correct, guys. That means that if one car gets better gas mileage than another, will it use more gallons of gas in an hour or less gallons of gas in an hour? It's going to use less. Exactly so. Mr. Petersen, his brother, and his wife fill up their cars at a gas station and hit the road to visit Mr. Petersen's other brother in Pennsylvania. He doesn't live in Pennsylvania anymore, but this problem wouldn't work if he didn't. Car number 1, Mr. Petersen. That's me. Mr. Petersen in his Subaru Outback. Mr. Petersen drives a Subaru Outback Sport, which has a fuel tank capacity of 17 gallons and uses 2 gallons of gas each hour on the road. Can you write the amount Mr. Petersen has left in his tank as an equation and a graph? You can make a table if you want to, but I'm not going to require a table. If you can just write that as an equation and then graph that equation onto that coordinate plane, that's what I need from you. But if you want to make a table to kind of help you with that, you certainly can. Give it a try, guys. Let's see how it goes. And beep, beep, teach. X would be the number of hours, right? Because if I run out of gas and the gallons stop going down, time's not going to freeze. But if someone could freeze time, then the gallons would stop going down because I wouldn't be driving anymore. Oh, oop, oop. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Hey, why couldn't they find any Foresters at the Subaru dealership?
Why?
Because they were all out back.
Why did the shoemaker twins?
There you go. All right, guys, here we go. Let's see here. How about I get a little bit of help, and this one's going to come from Miss Addie. Did you make a table for this, or did you just go straight to the equation? Great. What was the equation you came up with? Yeah. Thank you very much. Very good. Y equals 17 minus 2x. Now, how would I graph that? Tell me how that's giving me instructions on how to make that graph. Very good. Yeah. Which on my screen looks like down 2 over 2, but that's because every 2 boxes counts as 1. Otherwise, it would be really difficult to see. There we go. That's all I can fit. So I'm going to go ahead and connect those. Do you think a solid line is appropriate for this, guys? Yeah, because the gas is slowly going down. But notice I'm not putting any arrows on it because I can't travel back in time and put more gas in my tank than 17 gallons. And also, I can't, once I've hit 0 gallons, I can no longer drive and lose gas and go into the negatives, right? That would be awesome if you could just go into like -3 gallons and then it would be like, okay, but just gas up when you can. All right. Car number 2, Lars. Lars and his hybrid Elantra. Lars is my brother. Mr. Petersen's brother, Lars, drives a hybrid Hyundai Elantra, which has a fuel tank capacity of 11 gallons and uses only 1 gallon of fuel per hour. Represent how much gas is in Lars's tank as an equation in a graph. Put it on the same coordinate plane. Put it on the same coordinate plane. How much gas is left in Lars's tank over time? Make an equation in a graph, a table if you want to, but you don't have to. Give it a try and teach. It sounds miserable. Yeah, I feel like you still. I think I'm a 6 hour stopper. Like every 6 hours, I think I have to get out and stretch my legs and. Yeah, I hear you. I hear you. All right. Can I get you guys back up here in 5, 4, 3, 2, 1? Use this for Lars's cherry red Elantra. All right, what's the equation you came up with for the? Oh, by the way, that was an excellent countdown from 5, and I think you guys way deserve a point for that. All right, let's see here. Can I get a little help? No one there today. Oh, there we go. Claire, what was the equation you came up with for Lars's Elantra? Excellent. Very good. And how do I graph that? Mm-hmm. Yeah, down 1, right 1, which to you looks like down 1, right 2, but that's because I'm using every 2 boxes to count as 1. So don't try not to get too baffled by that. Well, I think it depends. I think that depends a lot on a lot of factors. Like I would say it's better in this regard, but I still think Outbacks are cooler than Elantras. But it's okay because we all have to bow down to the best of them. Car number 3, Miss Allander. Mr. Petersen's lovely wife, Miss Allander, drives a pretty red Chevy Silverado pickup truck. Yes, Miss Allander's vehicle is more manly than Mr. Petersen's. Yes, she lets him know that all the time. You don't need to. Anyway, her Silverado has a fuel tank capacity of 20 gallons and uses 5 gallons of fuel every 2 hours on the road. Represent the fuel she has left in her tank as an equation and a graph. Give it a shot, and here we go. It is cooler, Mr. Petersen. Teach! Yes, that Silverado is pretty great. Oh, we could drive a Humvee. Humvee, I think the equation would be 100 minus 10x, but I don't want to make that I don't want to make that a coordinate plane. There's a sad thing of it though, where the order in which they are fuel efficient is the reverse order of how cool they are. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1. Here's the Silverado. Let's see here. Can I get a little bit of help? And this is going to come from Aria. What was the equation you came up with for that Silverado? I'm glad we're talking. So take a look at what's going on with the with this. It's like the fuel tank capacity minus the gallons per hour times the number of hours, right? So 17 minus 2x, because I have a fuel tank capacity of 17 gallons and lose 2 gallons every hour. Lars has a fuel tank capacity of 11 gallons and loses 1 gallon every hour. That's why there's the secret one. How many gallons of gas is my wife's Silverado using over time here? If it's 5 gallons every 2 hours, I think. Uh-huh. And how did you get that number? And let's just leave it as a fraction, and then we can get an equation, right? Y equals the fuel tank capacity minus, you said 2.5, we're going to call it 5 halves x, because that's going to make it easier to graph, okay, Arya? Where's that telling me to start? Good, and then where's it telling me to go? Oh, not quite, because up 5 would mean that it's getting more gasoline as it drives, which would be really cool. That'd be awesome. That's fuel efficiency. If it's creating gas, now we're talking. So it should go, instead of going up, it should go down 5 and over 2. Very good. Down 5 over 2. And then we connect those dots. So there we go. We've got these 3 vehicles driving on the road, and that's the situation we have here. My question is, when we look at these 3 situations, do you notice anything? Well, first of all, do you notice anything about this picture? Yeah, there's a doggy. That's a dog over there on the left. But do you notice anything about this graph? And so I want to ask, do you notice anything interesting about this graph? And what do you think that means in terms of the story? Use words like Silverado, Outback, Elantra, hours, gallons. Like, I want to hear those words when you say something about that you realize here. So go ahead, guys, give it a try. Talk to each other. What did you notice about our graph? Teach. Here you go, sir. Did you notice anything about this, by the way, before you go?
Oh yeah. They have at the 6th hour they
Mm-hmm.
all intersect.
Which means what?
It means that like at the 6th hour they're all in the same place, but because of the different because of how much each subtracts, the
Mm-hmm.
different rules that apply with the
Mm-hmm.
equation, they change their.
Perfect. Love it. Go ahead and take that. That's good. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? LED, do you notice anything? Yeah, and specifically, how many gallons of gas do they have after 6 hours? Awesome. This point 6, 5 means that after 6 hours of driving, all 3 vehicles have exactly 5 gallons of gas. That's perfect. And this is what we call a system of equations. A system of equations is a group of equations that we graph together, and the solution to that system of equations is the place where they are all the same at the same time. So for instance, this solution to this would be 6, 5, because after 6 hours of driving, every single vehicle has 5 gallons of gas. How many of us feel like we've got that just fine? Great, let's do the next one. Let's do the next one. This one's a little bit bigger, so if you need more graph paper, like if you used up all the space on there, you can go ahead and grab a little bit more over there. This one is still in quadrant 1, but it goes up 30 and right 10. Okay, just make sure you count the boxes. And take your stuff just in case. Yeah, might as well. 10. Go ahead and make that coordinate plane for me, guys. I don't mind you chatting while you do it, but just make sure we're getting that too. 30, actually. X-axis is just 10. Awesome. Go ahead, guys. Yeah, make it so it's 10 to the right, 30 up. And while you guys are doing that, let's go ahead and introduce this story. We probably are going to have to take this story into tomorrow, so make sure you hang on to this paper because I don't want you to lose that because we're going to start with that tomorrow, okay? Apes Escape! Guys, is Apes Escape something young people are even aware of? No? Guys, it is one of the weirdest video games ever created. It involves time travel, super intelligent apes, and animal abuse. No kidding. Yeah, the basic idea of that game is like a super smart ape invents time travel and goes back in time to mess with humanity. And your job is you have a net and you have to catch all the apes from back in time. But the thing I remember the most about that game is the net has a really short handle, so you'd be chasing an ape and it's like, and he's running away from you. You could barely get him. But pretty early on, you unlock the first tool. This is what they call them. They call them ape catching tools, which is a stick. The stick is slightly longer than net. So you chase him with the net, going like, and you keep missing. You'd be like, forget this. You change over to the stick, and it's like crack, boom, and then he falls over, and he's like, oh, I'm dizzy, and you're like, yeah, that's true. And you grab him in the net, and you call it good, guys. This game is all too real, and I highly recommend you look it up. It is ridiculous. Anyway, let's talk about apes do not escape. Anyway, suppose that there are two apes in a lab, Benny and Jet, who each have a lever in their cage, and each ape can pull the lever at precisely 10:30 p.m. each night to receive treats. They have a 1-second window at 10:30 p.m. precisely where they can pull it, whoosh, and they get treats. When Benny pulls the lever at 10:30, he gets 4 treats. So, yeah, he pulls it, clunk, 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 he gets 4 treats. Now, when can he get more treats? The next night. Now, when Jet pulls the lever, she's supposed to get 3 treats, but her treat chute is jammed. She only collects treats every second time she pulls the lever, but she receives the treats that didn't fall from the day before as well. So if she pulls it, clunk, 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 nothing comes out. But the next day, she pulls it, clunk, 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 and how many come out? 6, precisely so. So this is where we're going to end today, and I just want you to think about this, and we're going to start tomorrow with this. Yes, they are apes without hope. Benny and Jet have been hoarding treats, and right now Benny has 5 saved up, and Jet has 10. Remember, Benny gets how many treats when he pulls the lever? And then Jet gets how many treats every 2 times she pulls the lever? So, when these 2 apes have the same number of treats saved up, they are going to make their escape. So they agree, like, they look at each other through the glass window, and they're like, when we both have the same number of treats, and they line them up and see if they match. And if they don't match, they put their hand up on the glass on either side and say, maybe tomorrow. And then they try again the next day. So we'll finish this story tomorrow. You guys did win the scoreboard game, so you can put your Stuff away. Head back towards your assigned seats unless you're on the start team, which I don't think anybody is. But that's going to do it.